So next is your next topic I am going to take, that is your imperfections in solid. Next one I will take it is imperfections. It is your imperfection. Next one I will take imperfections in solid. Imperfection in solids. Okay, this is a new one topic, imperfection in solid. So what is this imperfection in solids? When I will just start with this one, I will say I created defect, or we can create the defect like this. Is it not so? Okay, defects are, just keep in mind, defects are already present in our nature. We are just studying those one because I will explain it to you. So I will say we can create the defect like this, but those defects are already present. So imperfections means basically the defects that is present in a solid. We're discussing crystalline solids. In crystalline solid, we're discussing ionic solids. In ionic solids, we know that there is a regular three-dimensional pattern. Okay, regular three-dimensional pattern. So now, before we start, imperfection means defects in the solids. This topic is also very important. First definition that I am going to take, that will be your ideal crystal. Ideal crystal. I hope so. From word here, it is clear to you. Ideal means where the atoms, ion or molecule, they occupy the exact position. They are present at their exact location, that we call it as an ideal crystal. What is the meaning of this ideal crystal? If definition I'm going to write down, an ionic crystal having same unit cell. Let me write down definition. I will show also. It is the ionic crystal. Ionic crystal, okay, having same unit cell. Ionic crystal having same unit cell. Unit cell, smallest repeating unit. Okay, smallest unit repeating unit cell containing same lattice point. Containing same lattice points. An ionic crystal having same unit cell containing same lattice points throughout the crystal. Same lattice point throughout the crystal. Okay. Ionic crystal having same unit cells containing same lattice point throughout the crystal. Okay, throughout the crystal, if they have the same lattice points, same point, okay, throughout the crystals, then we called it as your ideal crystal. This we called as ideal crystal one. Ionic crystal having same unit cell containing same lattice point throughout the crystal. This we called as your ideal solid, ideal crystal one. Means how you will consider it. Suppose all of you are present in a morning assembly. All of you are present there, and all of you are standing in a straight lines. Okay, all of you present standing line without any. You can say no one is missing from the line, and there is a regular three-dimensional order. So that we called as your ideal crystal one. Yeah, ideal solid one. Okay, ideal solid one, that we called as your ideal solid. Yeah, ideal crystal one. Now suppose this is the ideal one. Ideal, you know that the ideal things basically just like I will say we discussed ideal system does not exist. In thermodynamics we discussed isolated system. So 100% isolated system is not possible. Like ideal crystals, this is a definition of ideal crystal, but actually the ideal crystals, they are not going to be exist. So there must be some defects. What kind of defect will be there? Like if I will say you ki, one of the student, okay, you are all standing in a long lines, or you are standing in a long lines, and Eric is not standing. Okay, Eric is not standing in a line. He is standing somewhere in between. So what should happen? He is supposed to be in a line, but he is not in a line. He is supposed to be in a line, but he is not in a line. He is standing somewhere in between. He is standing somewhere in between. So what happened, due to which a defect is created? A defect is created. Okay, he's not standing in a line. He is standing somewhere in between the line. So one defect is created. Like any other type of deviation. Now suppose you can say the front student is standing at class. The line is starting from the row 1, and after that one the line is full tilted. So there is a creation of defects. Let me explain it again. Ideal crystal, ionic solid, having same unit cell containing the same lattice point throughout the crystal, that we called as a ideal. Let me draw first of all the ideal one. Ideal lattice I will going to draw. Suppose you are all standing in a line, okay? Like this, you are all standing in a line. These are solid one, these are the lattice points. You are all standing in a line. So this is the ideal one, okay? But what happens? Any deviation from the completely ordered arrangement, okay? Any deviation from completely ordered arrangement, okay? This is the ordered arrangement, and if there is any, okay, if there is any deviation from this behavior, then we call it as your defects. Like this, I told you ki one of the Eric not standing here should be here, he is standing somewhere. Fine. So what happened? Due to this one, a defect is created in a solid. Its position is here, okay, it is not present here, it is present somewhere here. It can be more than one, I'm just explaining. Other way, what will happen? The row 1 is standing here, but he is standing like this, or behind this one, the full line is tilted. So due to which what will happen? There is a creation of a defect in a solid. In a solid, defect is created. Now, depending upon that, we have the two type of defects. We call them as a point defect and a line defect. We call them as a point defect and we call them as a line defect. We call them as point defect and line defect. From what it is clear, the point defect means a defect which is across a point, that we call it as a point defect. And line defect means when the defect is created throughout, okay, the line, puri line, that is tilted one, that we call it as your line defect. So here we have point defect, here we have the line defect. In our syllabus, line defect is not there, okay, point defect is only there. So ideal crystal not going to exist in the nature. How defect is created? Okay, there is a defect. This point defect, this is a line defect, that's fine. How defect is created? What happened? You can say at absolute zero. Now, second important thing that you must know, at absolute zero, at absolute zero. What is the meaning of absolute zero? Absolute zero, I hope so all of you are knowing it, okay? Minus 273.15 degrees Celsius. Absolute zero means 0 Kelvin temperature. Absolute zero, 0 Kelvin temperature. At absolute zero, all ionic crystal show well-ordered arrangement of ions. The scientists, they just mean to say at absolute zero, all the ideal crystal, all the ionic crystal, there will be no defect and they will show up ideal. This condition will be at the absolute zero. As temperature will keep on increasing, okay, as temperature will increase, due to the increase in temperature, what will happen? These particles, they will start vibrating above their mean position. They will get an extra kinetic energy, vibrational motion will increase, and due to this arrangement, okay, temperature increase karne se, there will be defect is created. One of the particle can jump into the interstitial site, or other way, it can happen in a different way. So with the increase in temperature, a defect is created. And one formula I will give you how it is related. It is small n is equal to capital N e raised to the power minus W by 2RT. Small n is equal to E minus W 2RT. This formula is not there in NCERT. No need to prepare. You will not get any numerical based on it. It is just the relation between the number of defects and the number of particles. Here, this N means defect, number of defects. This means number of defects. N means number of particles. Here we have number of, this means number of particles. Number of particles, and W by 2RT is work function, energy required to produce the defect. It is basically complete one. Is the energy required? It is energy required to produce the defect. Energy required to produce the defect. You need not to prepare this formula. Your main focus on this one part only, that is a point defect and a line defect. N is the number of defect. You can just get it very easily. The number of defect that is created, it is exponential. I will explain it again. Number of defect created is exponential to the temperature. As temperature increases, number of defects will keep on increasing. Just see, I will just start from the beginning. So, ideal crystal, where all spaces are occupied as in a unit cell, lattice crystal, that we called as your ideal one. Now, what happened? This ideal state is possible only at the absolute 0 Kelvin. Okay, absolute 0 Kelvin, that is minus 273.15 degrees Celsius, very, very low temperature. As temperature increases, defect is created in a solid. Different type of defect is created in a ionic solid. We have a relation small n is equal to capital N e raised to the power minus W by 2RT. W is a work function. R, you know that gas constant. T is the temperature. Small n is the number of defects. Capital N is the number of particles. Okay, number of defects and number of particles. Total number of particles कितने हैं? Number of defect कितने create होंगे? So n is equal to n e raised to minus W by 2RT means number of defects and the temperature, they are related to each other exponentially. As temperature increased, then defect will be created. Defect will be created. This is a little bit concept of defects. I will go imperfection in solid or defects in it. So we'll just discuss about the point defects. In point defects, we have the classification. Let me give you that classification. One minute, please. Okay, just give me a moment, please. Just give me 1 minute, please. I'm coming. Okay, just give me 1 minute. Okay, I'm so sorry. I was a little late. I hope audio video clear. Let me continue. So we are going to discuss the point defects. Just focus on a board. I hope so you got the idea of the point defect. Okay, not a line defect, point defect. Point defect further classified into the 3 types. We have the point defect of 3 types: stoichiometric defect, stoichiometric defect, Then we have non-stoichiometric defect. Stoichiometric defect, non-stoichiometric defect. And third one, we have the impurity defect. Third one, we are having a impurity defect. So we have basically these three type of defects. We have stoichiometric defect, we have non-stoichiometric defect, and we have the impurity defect, under point defect. These are the three further classifications. Under stoichiometric, okay, I will explain what is the meaning of stoichiometry, what is the meaning of non-stoichiometry. Under stoichiometrical defects, further we have here, I will not make you confused, NCERT rating of 4. First, let me explain you two only. We have Schottky defect and we have the Frankel defect. Schottky defect and we have a Frankel defect. Okay, under stoichiometrical defect, we have Schottky defect, we have the Frankel defect. Like under non-stoichiometric, we have further two defects, that will be your metal excess, metal deficiency. Metal excess, metal deficiency. Further, we have the classification, then we have the impurity. These are the classification under the point defects. One by one, we are going to catch each one. First of all, we are going to discuss with the stoichiometric defect. First of all, we are going to discuss about the stoichiometric defect. This stoichiometrical defect, first of all, we are going to discuss it. Just give me a moment, please. Okay. First of all, we are going to discuss stoichiometrical defect under point defect. Okay, just wait. So we are going to start with the stoichiometric defect. First of all, we are going to discuss about the stoichiometric defect. What is the meaning of this stoichiometric defect? Basically, these defects, what is the meaning of stoichiometry? Stoichiometry means these defects in which the number of positive and negative ions are exactly same as given indicated by the chemical formula. Suppose I will take NaCl. What is the meaning of stoichiometry? NaCl, ratio between the Na and Cl is 1:1. 1:1. What is the meaning of this? It means that if I'm having 100 sodiums, then I must have 100 chloride. अगर मेरे पास 100 sodium है, तो I must have 100 chloride, so that ratio that will remain 1:1. That is a ratio in the formula. Now defect is created. First type of defect, stoichiometrical defect is created. Temperature increase and defect is created. What type of defect is created? After the creation of the defect create ho gaya, fine. After the creation of defect, still the ratio between the cation and the anion, again it will remain 1:1. Again it will remain 1:1. मतलब जो फार्मूला में रेशियो है, okay, the ratio that is present in a formula between the cation and the anion, that should be same, okay, that should be the same as given in a crystal lattice. Same ratio crystal lattice में होगी, रेशियो में चेंज नहीं होना चाहिए. तो अगर 100 सोडियम है तो 100 क्लोराइड होंगे, 90 है तो 90 होंगे, 89 है तो 89 होंगे. Ratio should be maintained. That is for the stoichiometrical defects. You will get a better understanding. I will take the example for it. For stoichiometrical defect, first thing, I'm going to write down some important points, what things you are going to keep in mind. First thing, ratio between cation and anion should be same as in a formula, should be same as in formula. Okay, ratio between cation and anion should be same as in a formula. First thing. Second thing, crystal should remain, very important thing, should remain electrically neutral. Crystal should remain electrically neutral. क्रिस्टल के ऊपर कोई फर्क नहीं पड़ना चाहिए, मतलब it should not have a positive charge or negative charge. Once defect is created, it should remain electrically neutral. Crystal should remain electrically neutral. Third point, whatever defects we are going to discuss, we are discussing only in ionic solids. Only in ionic solids. We are discussing only in ionic solids. Okay, that's very important thing. We are not discussing metallic. We are not discussing molecular. We are not discussing the covalent. Okay, we are discussing only of the ionic. Whatever we are going to discuss here, we are going to discuss only in case of the ionic solids. So ratio between cation and anion should be same as in a formula, number 1 point. Crystal should remain electrically neutral, number 2 point, and it occurs only in a ionic solids, or only in a ionic solids. So under this one heading, under stoichiometrical, we have two defects. One is your Frankel and one is your Schottky. First of all, I am going to discuss with you the Schottky defect. Schottky bolo, Scotty bolo, whatever you want to pronounce it, you can pronounce it. I am going to discuss this type of defect. This defect comes under the heading. This defect comes under the heading stoichiometrical defect. Let me draw first of all the ionic solid. Ionic solid, cation, anion, cation, anion, A positive, B negative, A positive, B negative, B negative, okay, so suppose this is a crystal in front of me, and I will consider this one as a ideal crystal. Okay, everywhere is everything is present in its exact position where it should be. Lines I should not draw as a rule, but just for the explanation only, just for the explanation, I'm going to draw the lines between them. Okay, this is the ideal crystal. Yeah, lines, these are not bonds. Okay, keep in mind these are not bonds. I'm just writing it so that I can able to explain it properly. Now find out the positive and negative charge in this case. A positive 1, 2, 3, 4, 5, 6. I'm having a 6A positive. Check out the B negative. 1, 2, 3, 4, 5, 6. I'm having a 6B negative. Overall, it is electrically neutral. Okay, overall it is electrically neutral, and ratio between A is to B is 1:1. Ratio is 1:1. Okay, ratio is 1:1. So right now it's an ideal crystal. It is electrically neutral and ratio is 1:1. I want to create a Schottky defect. Yeah, Schottky defect. What I will do, because rules are knowing it, ratio should remain same, crystal should remain electrically neutral, and occurs only in a solid state. In this type of defects, what will happen? One of the cation is missing from its position. So number of cations now remain 5, and one of the anion is also missing from the neighboring site. One of the cation and one of the anion, they are missing from the neighboring site. Defect is created. Absent hai, school hi nahi aaye. Okay, they are absent one. But again, if you will see ratio, okay, ratio between the cation and anion, overall crystal is electrically neutral. Overall crystal is electrically neutral. Okay, we have 5 A's and we have the 5 B's. Overall, it is electrically neutral. Ratio is 1:1 again, and is in ionic solid. This type of defect that we called as your Schottky defect. It occurs in pair. Okay, it occurs in pair. When one cation is missing, then simultaneously one anion is also missing. If one of the cation is missing, then one of the anion is also missing. So this defect we call as a Schottky defect. I will go for the next one. in Schottky defect, what you are going to keep in mind, let me draw first of all the ideal again, ideal crystal. So this is A positive here. This is A positive here. Fine. Okay. This is the ideal crystal. What is the Schottky defect here? I will explain, Akriti. Now let me first of all respond to Sanvi. So this is the ideal crystal. Fine. What will happen when Schottky defect? How this defect is created? One of the cation is missing from here. Right now, we have 6A positive and we have 6B negative. One of the cation is missing, so we'll have now 5A positive. Okay. At the same time, because we need to maintain its electrically neutrality from neighboring, one of the anion is also missing. So I will get a 5B negative. So what happened? The Schottky defect is occurring in a pair. Okay, the Schottky defect is occurring in a pair. One of the cation and one of the anion, they are missing. Ratio again 1:1. Okay, we have 5A and 5B. So ratio again is 1:1 between them, as given in a formula, because in formula ratio was 1:1. Here ratio was 1:1. After the creation of defect, again ratio is 1:1. And because we have 5A, 5B, so overall it is electrically neutral and occurs in ionic solid. So like this, I can create a Schottky defect. Like this, I can create a Schottky defect. Now, one question, good question I've got. What happened if it is something, it was like we have 6A positive and 4B negative. Ki anion ही गायब हुए. Okay, anion are missing, but cations are not missing. ये भी defect है. This is also a defect. But this defect is not Schottky defect, and this defect is not stoichiometric defect. This is not Schottky, and this is not stoichiometric. Okay, this is not Schottky. This is not. Okay. This is just 1 minute. Okay, just go through it. Just give me a 1 minute. Okay, I will. Just give me a 1 minute, please. Okay, I will be back